Right, hello. Welcome to learning event for week 2. And let me just get the screen and then we can get going on this one. There we are. All right, so put this up in the corner. Right. This is still unit 1, so it's still on instructional resources. If you think back to last week, we got 4 weeks, and within these 4 weeks, we're going to do resource types, which we did last week. This week, we're going to look at laboratory risk, safety, health and safety ideas within the laboratory, and also when you move outside the laboratory to go to, science expos or various things like that. So we're not going to look at much standard laboratory issue equipment. That's what you should be doing at school, and you'll be able to pick that up. It's not so important for me at this stage to do that for you. Improvising, there are, of course, always issues with improvising equipment. Sometimes when you improvise equipment, the people think that you're giving them second-rate, second-class stuff, junk. Often we create these, improvise this equipment, not so much because we can't get the real equipment or too expensive, but because sometimes it works better. So I'll illustrate 1 or 2 little aspects of improvising, which is I think a little bit more than just taking a 2-liter Coke bottle and cutting the top off and saying, now I've got a funnel. I think the improvisation in the FET revolves much more around, excuse me, things like induction coils and hovercrafts and things like that. The cutting off the Coke thing belongs to the lower level, I think. And then the ICT resources we'll look at in week 3 and 4. So if we're looking at this one, I've said before, it's about the risk, etc. And it's also a little, but it's mainly about safety. So this week will be about safety in the FET laboratory. So it's important that you do risk assessments. What is the risk of something going wrong? And once I've identified that, how do I mitigate against it? How do I make sure that doesn't happen? So you'll find that we always should have a risk assessment in the practical work. So when you're doing a work lesson plan for practical work, there should be a risk assessment in it. And that's what I'll be looking at in your lesson plans later in this particular module. The safety should also be included in the schemes of work. And if you look in the caps, you'll sort of tentatively see it there. You'll find that there's a bit of repetition in this week, but it's done basically because you need to get a grasp of the safety aspects, because it's critical. If someone gets damaged badly in your classroom and you were irresponsible, you're going to be paying for someone else's medical bills for the rest of your life, maybe. So be very, very careful, be aware, and be preventative. So you need to have regular inspections of the safety and first aid equipment. Later, I'll talk about the fire extinguishers. If you have fire extinguishers and you haven't checked them and noted that you've checked them and serviced them once a year, and you have a fire and they couldn't be used, well, you may be in trouble. So check all this equipment, check your first aid kit, check the fire extinguishers, and keep a record of it. If you spot a hazardous situation, do something about it. If there's an open container of mercury, which I've seen in 1 or 2 laboratories one at least that I've been to, it's a hazardous situation. Something has to be done about it. Don't store food and drink and chemicals and things like that. Some laboratories have the privilege of having a fridge, and only science stuff must be in there, not the lunch, etc., because that becomes problematic. Keep the chemicals in their original containers. If the container is damaged, it usually means the chemicals might be damaged as well. So original containers, keep them all labeled properly, proper labels that don't wear off or rub off. You've all experienced it. You will at some stage. When you go into a lab and the lab is full of chemicals, or they're on the floor, or they're in the fume cupboard, and they've been there for the last 6 months, make sure that you keep your laboratory clear of all these things. Ensure that the chemicals are locked in stored rooms. Once you've done the potassium or the sodium with water experiment, then the kids want to take a big chunk. So keep the stuff under storage. And also know how to get rid of stuff. I mean, I've been in a school where they had, I don't know, the guy was crazy on carbon tetrachloride before me. There were these big Winchester bottles of 3, 4 of them of carbon tetrachloride. I had to get rid of that. And you can't just throw it down the drain because it's carcinogenic. And what a schlep to get hold of a company. The guy comes in his HazPack and he has a sealed container that puts the thing in. So when you come to a school, look in the storeroom and make sure that everything there is okay. And that there isn't stuff there that shouldn't be there. Essentially, you're in charge of that laboratory. You're responsible for the safety. So be a good model. You know, don't take too big a piece of sodium just because you want to see a bigger explosion. Don't listen to the learners who say a little bit more, a little bit more. Be kind of, well, PPEs, personal protective equipment these days is all in the news. You should be appropriately dressed, goggles, laboratory apron, coats, laboratory coats. And remember, you can't just use any old coat. It should be really cotton because that burns. It sounds silly to say that, but it burns. If you get these synthetic lab coats, they don't really burn. They just melt into you. So if it catches on light. So be careful of the PPEs that you get. Critically, if there's a practical going on in the classroom, you cannot leave it. You have to be there and you have to watch. You know, I always make sure that I position myself in such a place that I can see the whole class. You can't you can't go and help a little group when you've got 30 kids behind you working with Bunsen burners or spirit burners or whatever. You have to be aware the whole time. And this comes about in your risk assessment that you've done in your lesson plan. Can I help little groups in this sort of practical, or do I have to keep myself apart and watch the whole thing? And again, never allow them to take chemicals out. Eating in the laboratory. You know, I'll come to you a little bit later to say, rather tell a story about it than just have a rule. And I'll explain to you then what I mean by that. The learners should know where the safety equipment is and the cutoff switches. Whenever I had a class for the first time, I'd always ask them, where's the main trip switch for this laboratory? Because essentially, I'd like them to know it in case I'm the irk that's being electrocuted there, and I'd like the learners in the class to know where to go and switch the thing off. Because I might be jumping around, jerking around probably, and not being able to tell them where it is. So where are the fire extinguishers? How do you use them? The fire blankets, the first aid kit, the eye wash. Try to get eye wash bottles. Otherwise, you can get a squirt, you know, a squeezy bottle to squirt stuff out of people's eyes if it gets in. But some of the chemicals, you know, they hold the test tube this way, it squirts out into someone's eye. You've got to be ready to deal with splashes in the eye. What do you do if there's an emergency? How do you get out phone numbers near the phone, or keep them on your phone these days? I think this is an old sort of idea. And do the drills. Speak to the students reasonably, you know, enough. There are lots of little things as well. Look around the class. Make sure that the people with long hair have their hair tied back. Make sure that there are no loose sleeves, etc. And then always know the potential risk factors and mitigate or do things to stop them happening. Understand the potential hazards of materials, and sometimes we don't always get this one. Check the equipment before. Make sure the learners know it. Right, so I think this is just a bit of a repetition of a previous slide. The first aid kit. All laboratories should have a first aid kit, and they don't have to be elaborate. There are a few basics. A leaflet for guidance for first aid, but it's probably too late to read the thing when you've got a problem. But it's useful to have it in there in case people don't actually know, and it's you that's got damaged. You need some adhesive dressings, plasters. Sterile iPads is always a good thing, especially if they've splashed in the eye and you squirted the stuff out. Critical to have an eye wash bottle. You get very fancy ones that sit on top of the eye and you just squeeze and it rinses the eye out. But a squirting bottle that's got reasonably distilled water and things in it. Sterile bandages, all this sort of thing. Disposable gloves. Disposable gloves you should have to put on for infection control, but I can relate a little story that many years ago when my wife was teaching, some little guy in grade 7 or 8 cut his hand. So she said to him, okay, just hang on, let me just get the gloves. So his response to her was, Miss, do you think I've got AIDS? She said, no, but how do you know that I don't have? Please must get the gloves. So you see, it's protect everybody using these gloves. When you go to your teaching practice, make sure that you have a pair of gloves, plastic gloves, in your kit at teaching practice. Burn shields, and I'm going to show you a little video clip on burn shields that I made this morning. You can't have tablets in there. You mustn't have headache tablets. That's not for us to give kids that have got headaches. They go to the secretary sorts it out. It's not for you to give aspirins and things like that. So no tablets and cough mixtures and things like that. It's the basics for probably physical accidents that happen. Right, let's have a look at the first aid kit.
Right, for the first aid box, if you look here at this one, this is just the one that I've got at home. It's got a few compartments in the top, some compartments inside, various things like that. Of course, this is not the one that you would use in a science lab, but the structure, the box itself is the same. Now, there are a couple of things that you need to have in the first aid box. Burns. Probably one of the biggest accidents that you'll have, or the biggest injuries that you'll have in a science lab, is burning. Now, of course, if they burn themselves, they can go and hold their hands under cold water. That seems to work very well, in fact. Otherwise, you can have a burn shield gel. This is quite a useful one to have because you just use little bits of it at a time and you can just carry on using it. So it's value for money. You should also have some of the bigger burn shields. This is for the bigger burns. 1 or 2 in a box is usually fine. But once you open it up, you can't store it again. It has to be used. Of course, you must have rubber gloves for various reasons, infections, etc. And I'll talk to you a little bit about that later in the lecture. Some plaster for those little cuts and things that they have. You can also have some antiseptic gel. This just happens to be an ointment that I tend to use. Just remember that don't put the ointment on the wound, because then you contaminate the tube. Take the piece of plaster, put some of the ointment on the plaster, and then place it over the wound. In that way, you can reuse this and keep it as an antiseptic.
But I think this is a little bit about the fire extinguishers, because we do have fires in the laboratory.
All right, so with the fire extinguisher, now remember you're teaching about a fire extinguisher for general life, because they're going to come across these things in their kitchens, in caravans, in different places where they go to. So let's just have a look at it quickly. First of all, this is an ABC, so it can be used on most fires. And then you should always check that it is in the green zone. If it's in the red on either side, it means that it has a problem. They should be serviced every 6 months, and they should be serviced after you've used them. That's why I never demonstrate this in a class. Although it is worth demonstrating because it makes a big noise when it goes off and it scares people. So they drop the fire extinguisher because they're not aware of the noise. So the first thing we need to do is pull out the pin. And it's in there for a reason, to stop the kids in the class playing with it. And also to let people realize that the thing has not been used. So you pull out the pin and you aim it at the base of the fire. But of course, it comes out with a loud noise and a rush of air. So if you hold this on some burning equipment on the table, it blasts everything onto the floor. So for little fires in your classroom, it's best to have a wet rag, which then will smother the fire.
All right, I'm going to just talk a little bit now about rules. When you walk into the laboratory, you see these things. Do not touch chemicals unless instructed to do so. Never work when the teacher's absent. Only follow written verbal instructions. Do not try your own experiments. Don't eat and drink. Before using chemicals, read the label. I mean, that's quite important. When mixing chemicals, keep it away from your face. That's why we've got the squeeze bottles in the laboratory for their eyes. Unused chemicals should never be put back in their bottles. The reason for this is that often we contaminate it. We take out too much into a test tube and we put it back into the bottle, and then it gets contaminated. And if you've got oxidizing and reducing agents and things like that, you end up with bigger issues, explosions, basically. Try to wear safety goggles. And really, the 20 Rand, 25 Rand safety goggles that you can buy at a place like Builders Warehouse, the hardware store, those are usually fine. I can remember when we were at university, I mean, we wore sandals most of the time. But when we went to the chemical laboratory, we had to put on shoes. We didn't have our shoes, they kicked us out. Basically because of you walk on the floors, it's chemicals, drop stuff on your feet. So must be closed shoes. The loose clothes, untied hair, all of those things. I mean, you know, if the hair gets in the burner, it stinks. Burning hair is not a pleasant smell. And of course, it's dangerous. So tied back hair. So rather explain things, rather than just have a whole lot of rules, never, 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 rather explain why we have certain rules. It's quite important. Oh, I think it's very important. Don't use chipped or cracked glassware, because when you're heating it, it may just crack more and you end up with the stuff on top of you. Hot apparatus looks the same as cold apparatus. It doesn't feel the same. So they've been using a tripod. They finished using the tripod. It's been a flame on it. You start talking to them. They grab the tripod to move it. And out comes your first aid kit with a burn shield. Do not panic. Sometimes you're lucky and they don't panic. But there's quite a lot of panic. So you can learn to control that management as well. All right. I don't think I've ever put up rules. Don't. Swimming prohibited. Of course, people are going to swim here when you say swimming prohibited. If you want to stop them from swimming, then change the sign. Because now no one's going to swim there. So always start to think of how you're going to convey these laboratory rules. Maybe as a bunch of positives as opposed to a bunch of negatives. The basics, of course, laboratories are dangerous. Of course, the kids are interested in the stuff. And the more you let them use the laboratory stuff, the less curious they get, the more scientific they get, if you want to put it that way. So the big things you're going to have are burns. We've spoken about that. Spills, where stuff gets spilt, acid or something on their clothes. And exposure to, you know, various radiations, exposure to mercury fumes. You shouldn't be using mercury in a science laboratory. And that little thing we do with the mercuric oxide, or used to do, we don't do it anymore, basically because of the exposure to the fumes. The causes of accidents are inexperienced learners, lack of education, distractions, the horseplay that goes on. So when you're using droppers, they use them for squirting syringes. So control all of that. And basically poor equipment, broken equipment. And know where the stuff is. Just some random ideas. The bucket of sand. In previous laboratories, they have a bucket of sand for the fire. Well, you've got to teach the learners not to use the bucket of sand on people. Because if they end up with a bucket of sand on a serious burn, and they end up in casualty, the sister sits there with tweezers and pulls out each little grain of sand. You're not the most popular teacher in the school if you've allowed that to happen. So the sand is to smother fires that haven't got people involved, if you like. For me, the best thing is to have a wet cloth. I often just have a wet cloth at a table where they're working with flames, and that tends to work wonders if you get a small little fire. Lab coats and loose clothes we've spoken about. Eating and drinking. Here I like to talk about the phenolphthalein. The indicator phenolphthalein is the active ingredients of Brooklax. So if the previous class has been working with that, and you eat there and you get something into you, well, then you've got a runny tummy, a real runny tummy, where you run off to the loo pretty quickly. Don't drink from the glassware, another big issue that you see. Check the safety data on the chemicals. So teach the learners about safety data. Don't smell, touch, or taste chemicals. If you want to smell it, you hold the test tube like this and you waft the stuff into your nose. Okay. It's the wrong sort of stuff. You end up knocking yourself out. Never mix chemicals just for fun. Don't go for bigger volumes than what's recommended. Clean up spillages. That's also a big one. So have a mop or something like that in your classroom. Care when using strong acids and bases. Concentrated, strong and concentrated. And of course, you know, there's the difference, or there's this link between strong and concentrated. Sometimes some sodium bicarbonate solution helps a bit there, obviously with the acids or the bases. If you get some on you, wash liberally, seek attention if you need it. Never add water to acid, always add acid to water. And the reason being, very often it's an exothermic reaction, especially with sulfuric acid and water. So if you're adding the acid to the water, you don't have this massive sudden increase in temperature. I think with the splashing as well, if you pour it in, it's the thing that's the bigger volume that splashes. So it's the water that splashes. But you need to check on that one. I'm not too sure of that one. That's something that I heard, but I haven't actually confirmed it or not. Do the stuff in the fume cupboards if you have to. Hydrogen sulfide, I've spoken about this before. It's not a good gas. Might be nice in a stink bomb, but it's not good. When I used to have a fume cupboard and I needed to do some of these things, then we did them outside. So we'd go outside and do them out on the school playground. Smelling chemicals, we've spoken about that, waft it into your nose. The hot and cold, you know, that's that sort of thing. Just something that I don't think I've got here. If you're going to have a hydrogen gas cylinder or oxygen gas cylinder, they have to be strapped to a solid wall so that they can't fall over. Hydrogen is an interesting one. If it falls over and the regulator breaks off and the gas escapes, well, first of all, it becomes like a rocket-propelled rocket. And secondly, the hydrogen, when it expands, you know, when concentrated hydrogen expands, I think it's an exothermic reaction. So you've got a very good chance of an explosion happening as well. Don't leave flames unattended. Don't overheat test tubes. Face the mouth away from other people. And you've got to watch the kids all the time on this, because they sometimes get, you know, they get so absorbed that they forget what they're actually doing. You can't pour chemicals down the drain, not all of them anyway. So check that you know and the learners know what can and can't go down. Then we've got all our different symbols, which people should know about. You'll see them on the bottles. They're often there are multiple ones on the bottles. And you can make a game of this if you want to, although we'll probably do that in senior phase rather than in FET. This was quite a good sign that I picked up the other day. It's got everything in that's critical. Dress appropriately, proper supervision, know where the equipment is, no food, identify hazards, be careful of hot glassware, clean up. You can see it's a really nice one. What I liked about this one is stay bottom left-hand corner. Stay safe when conducting your lands by maintaining social distancing. So it's quite a modern, I think it must be, current COVID-19 poster. Right. Ammonium nitrate. You will have ammonium nitrate in your classroom, in your storeroom. We use it for various things. Often the ammonium nitrate is what we put in these cold packs. You know, if you're on a rugby field, if a guy or woman pulls a muscle or something, then you take the cold pack and you break the little container inside it, and the two chemicals mix, and then it gets very cold. Well, that's ammonium nitrate. But this is what happens if you don't store ammonium nitrate properly, and you probably know exactly what I'm talking about. Won't show the whole thing though.
Our Earth is like a treasure chest we have to watch over.
There are troubling new allegations tonight about that deadly port explosion in Beirut. Sources have told the Guardian newspaper that prior to the blast, dozens of bags of fireworks were being stored in the same warehouse as that stockpile of ammonium nitrate, which acts as an accelerant in a fire. In video from the day of the blast, you can see white flashes, what appear to be fireworks, going off before the massive explosion. former port worker told the Guardian newspaper he warned for years it was a disaster.
Right, let's stop that. All right, so can you see they had fireworks, they had ammonium nitrate, didn't keep the chemicals separate. It's a vicious explosion. So be careful of how you store stuff. You're not going to have that sort of explosion, but that's just volumes. So that's another thing. Don't keep big volumes of oxidizing, reducing agents and things like that in your storeroom. Small amounts is enough. Rather resupply every couple of years if you can. Right, just to look at laboratories quickly. I came across this in the Business Insider from the year before last. These are two laboratories at 400,000 Rand a pop that were built at Stellenbosch High School. Look, I'm not a big believer in these sort of laboratories. I want a flexible laboratory. I want loose chairs, etc. But that's what you can get, I suppose. But as their teacher says, on their own, these are meaningless. You need the enthusiasm and the love for what you're doing of the teacher. And as we spoke about earlier, the knowledge of the teacher. So let's have a look here. The Electisha, which is a website that we look at occasionally. Many schools do not have laboratories. In fact, 20,000 of South Africa's 24,000 schools in 2013 did not have laboratories. We're talking high school here. 83% don't have laboratories. So this is what teachers do. Store stuff like that. But in this particular school, they still had an 84% pass rate for physical science, with most getting over the 40%, which is a reasonable pass in physical science. So you can do things without laboratory. Not ideal, but you can. Another school, very, very often, I mean, many of us who teach have taught in science in places like this. In schools where there is no laboratory, overcrowded, and you do the best that you actually can. That's all that you can actually ask for, do the best that you can. And even if you do store your chemicals in a cupboard. We've got lots of alternative things. These are these kits. They're very useful. That everything you need in there, all the chemicals in small amounts are needed for all of grade 10, 11, and 12. Really neat, really can be used effectively. And I don't consider that improvised laboratory. That's a real laboratory. There are a couple of other things that are happening. There's the Science to Go. You can check what they do. They work quite a lot around the area where I live. It's CASME. CASME's up there in Natal. A lot of work that they do. They move with the mobile laboratories around and they train teachers and they work with kids in schools. So use the outside resources as well. The Cape Town Science Centre is really great to go to. There's a lot of really good physics that goes on there. My 60th birthday present was when my grandchildren took me as a surprise to the Science Centre there. I've never been there before. I've been to lots of science centres in the world, but never to that one. It's really good. Sibona in Johannesburg, in the central part of Johannesburg, been there as well. Also lots of really good stuff. You don't want to take a whole class of 80 there, but you can maybe take your science club, etc. I'm not sure about this Unisol Science Centre. I haven't heard of it before. I just came across it when I was researching for this lecture. But it appears to be working very well. This is just an example of the Science Centre in Cape Town, in Observatory. So there's lots of bits and pieces one can do. Kids get really involved. Well, so do adults. I've spent days in science centres in my life. The resources and equipment, Rutland is always the old traditional one with its, you can get just about anything from them if you can afford them. They're pricey. But there's lots of other little areas. I've just picked up two of them that you can look at. Improvisation. I spoke about the funnel, but sometimes the improvised equipment works better than the stuff you can actually purchase. On the top right-hand corner, you can see the purchased hovercraft and the little one that we make. Little one that we make works far better than that other one. And this induction coil on the left-hand side here. Sometimes we need to just look around and see where we can find stuff which is useful. Science outside. You saw we were the pond. This was one I came across earlier in the year when I was cleaning my swimming pool. fascinating to look at this one. Look at the shadow. Let's see if I can get this pen. I don't know if there's a pen here or not. Okay, I can't get the pens. But look at the shadow. The shadow is straight. But because of refraction, the pole appears to be bent. And then, of course, you've got some reflection there as well. This is really nice. So if you come across this sort of thing, it's a piece of equipment, which is not a piece of equipment. But it gives you a really nice explanation of, think about this one. I love this one when I realized what was happening the other day. And I took a photograph of it. Think about it. Think about how you could use it when it comes to light. Lasers, of course, be careful of lasers. They damage one's eyes. So I'm not going to do the clips and that, but we do access cheap lasers these days. You know, the little pointer pen. Nice to do light experiments with, but they can be quite dangerous. And then skills, you know, you can teach skills with just pictures. So you can have a laboratory like this. While we're talking about this, let's just have a look. I came across this. I mean, I've known about it. The centigrade Fahrenheit scale. Have a look here. Naught is there on centigrade, and Fahrenheit is there. Because 0 degrees centigrade is 32 degrees Fahrenheit. At which temperature is Fahrenheit temperature and centigrade temperature exactly the same? Think about that. That's an interesting one. It's -40 actually, and the way you do it is you just substitute. It's normal straight substitution, because that's what Fahrenheit is using centigrade, and that's what centigrade is using Fahrenheit. Just straight substitution, and you get at -40 they equal. So that's it. That's safety. Next week we'll start looking at ICT simulations, resources from that aspect. Let's stop off here. Stop share. Okay. Right. Thank you. The involvement tracker will be up as soon as this video is available, and then you can get onto that. Remember, you've got about 10 days to complete it from the date that the video becomes available. And I'm not going to be opening involvement trackers that have closed. So get onto the involvement tracker. I'm trying this time to ask questions which will give you and me indicators of your, not so much that you watched the video, although that is important, but some indications of where your gaps might be and where I don't need to focus on. Right, thank you.